Right, analyzing functions. So what we're looking at is almost always going to be graphically. So when we're analyzing functions, when they're in their graphing form, we know they can be in tables, we know they can be equations, all those things. Graphs gives us the most amount of information. So because this graph that I have on this page has 3 lines, 1, 2, 3, this would technically have 3 equations, 3 tables, 3 of everything, but it's only one graph. That's why analyzing a graph is a whole lot easier. So I'm going to move myself here so we can kind of see the question I have here. What are some important features of graphs, like the one I have below? So some of the big important features of any graph that you should be looking for are the slopes. We really want to deal with the slopes of these lines. So there's 3 different sections. Whoops. So we really want to find the 3 different slopes. Other things that are very important to look at with graphs is how many sections are there. So 3 sections mean there's 3 parts to this story. We want to look at the independent and the dependent variables. We want to look at these 2 points right here. This one and this one, they're called inflection points. It's where the slopes change. So we got this constant slope, we're going fine, we're doing good. Then right here, all of a sudden, it changes. And then at this point, again, changes. So points, slopes, change. And then the last thing is where the lines actually are. So, I mean, if I break out the highlighter here, everything below the x-axis right here that's highlighted in blue, that's a negative output value. So we plug numbers in. This is where the graph is negative. Everywhere in this blue, now I went over the x-axis a little bit. I don't know if I'm going to be able to take care of it too well. So anything below, see if I can do this a little bit better. There we go. It's still going to be, it's not perfect, but it's all right. So everything below that is where we are negative. Everything above that's where we're positive. So different parts of graphs that we'll look at also tells a story. So this graph over here, we've got our dependent variable. We've got our independent variable. It's trying to describe a story. So from here something happened, section 1. From here to here something happened. Then here to here something happened. All in relation of distance from home in time. So this first part, at time 0, distance was 0. So meaning before the thing started, how far were we from home? We were 0 feet from home. Then at some amount of time, let's just give it a value. Let's say 5. And let's just say 10. We don't know 10 miles, 10 meters, 10 feet. I don't know. Just some unit. We were 5 minutes into this. We were 10 meters away. Then let's say from this one, that's 15 minutes. So 15 minutes. And let's say this is now 15 here as well. I'm just making up numbers. Where am I? I'm just making them up. Okay? So 15 minutes into the experiment, we are 15 minutes in, 15 feet away, 15 miles away, whatever. Then to finish it, right here, let's say that was 25 minutes. We're back at 0. We're back home here. The distance from our house is back at 0. So if we look at the stories, Tom took his dog for a walk in the park. He set off slowly and then increased his pace. Okay, so in 5 minutes he was able to move 10, but then in the next 5 minutes he was only able to go 5. He slowed down. We can see that in the picture because this line is less steep. So he didn't increase his pace, he actually slowed down. So A is not our answer. So Tom rode his bike east up a steep hill. That makes sense, that's a pretty steep hill. After a while, the slope eased off. That seems to make sense. And then he raced down the other side. That seems to fit. But the problem with this story is it's describing this graph visually, which we don't care about. We don't care that this graph is visual like this. It's up a hill, less of a hill, down the other side. It's all about the units. When he goes up this steep hill right here, he's riding his bike up a steep hill. And then this is pretty fast because it's steep. Then from here, he's slow. So if we're riding our bike up a steep hill, we can't ride our bike up steep hills fast. So B is not our answer. C is our answer because Tom went for a jog. So jogging, he's moving pretty fast, pretty steep. He slows his pace. It's less steep, so it's slower. And then here's the key. When he's done talking to his friend, he walks back home. That's how we know that the line is no longer going up anymore. It's coming down. He's walking back home. So we can kind of see that. I'm going to use my buddy here, Tom the Elf, though we did like in class. These are basically the same ones we're looking at in class. Tom left his house to go for a walk. So he's at his house, and he just goes for a nice walk. Because it doesn't describe him changing speed, he's just walking. Our independent variable is time. And just like the last story, it's distance from his house. So as he's walking from his house, so here, 0, 0. So we start right here. And he's walking, not changing his speed. Our line does not change its slope. How steep this line is all dependent on the units, which we don't have, but it doesn't change. It's a constant slope because he has a constant motion. In the second one, Tom leaves his house to go for a walk and then decides to run after about 5 minutes. All right, so on the graph down here, I'm going to put the 5. Here's 5 minutes. He's starting at his house, 0, 0 distance. He's walking, he's walking, he's walking, he's walking. Then right here at 5 minutes, he decides to run. Now, it doesn't say that he's running back towards his house. So now what's happened is we have to show that he's moving faster. So we draw a steeper line. Because he's walking away from his house and then away from his house, that's why we have these positive slopes here. Maybe he was able to get 10 meters away, and then after some time he was able to get 20 meters away. He was just doing it quicker. Okay, Tom is going to run to the bus stop. So he runs to the bus stop, waits for a bit, and then walks home. So 3 parts to the story. So we have 3 lines. The first part is he runs. So that's quick. He starts at his house, 0, 0. Time is 0, distance is 0. And he runs to the bus stop. So here's the bus stop, however far away it is. The second part of the story, he's going to wait for a bit. Now while he's waiting, time is just clicking away, just keeps going. So, but he doesn't get any further or closer to his house because he's at the bus stop. So this is him waiting for it. This last part, where he walks home, since he's walking, not running, has to be less steep than this first line. And since he's walking home, he's losing distance. So his house, a lot of us are going to think that it's this dot right here. It's actually the x-axis right here. So he's going to walk less steep until he gets back home. We know he gets home because after some amount of time, don't care how far, his distance from home has become 0. So that's the whole thing about these distance time graphs and analyzing functions. So I kind of want to use one. I know I got a bunch more of these. I'm going to look at this graph right here. Okay? We want to describe the story. So let's say down here is time again. Let's say over here is, what would be a good one? How about, number of cookies. Number of cookies. So time in, let's say, minutes. So number of cookies we have. Let's be a little more specific. The number of cookies we have. So right now, start of the story, this 0, 3 means that at the start of this story, we already have 3 cookies. 0 minutes, we already have 3 cookies. Then at this next part, B right here, B is 3, 6. So in 3 minutes, we went and we got 3 more cookies. If we want to look at our slope, that's our rise over run, we could go from A to B, we could go from A to any dot that perfectly crosses the grid. We're going to see that the rate of change is 3 over 3, or simply 1 over 1. We get 1 cookie every minute. 1 cookie, 1 minute. 1 cookie, 1 minute. 1 cookie, 1 minute. Then from B to C, now we have to look at, we were gaining cookies. Now that the line is going the opposite direction, we're actually going to be losing them. Probably we're eating our cookies. So from B to C, right here, we're eating cookies. Or we're losing them. We're giving people cookies. We just don't have them anymore. We had 6. We end up with 4. Our rate of change is 2 over 2. It's negative 2 over 2 because it's down 2, right 2. Or in this case, negative 1 over 1. Down 1, right 1. Down 1, right 1. Then from C to D, we lose a lot of cookies very quickly. From C to D, we lose 3 cookies in a minute. Maybe we scarfed them down, maybe we dropped them on the floor and now they're all dirty. Whatever reason, we gave 3 cookies to people really quickly. That's just what happens. From D to E, we gain cookies back. From D to E, we have 1, 2, 3, 4. 1, 2, 3. So we gain 4 cookies in 3 minutes. But from E to F, we don't have any change in the number of cookies. We get 0 cookies over 2. That's the same as 0 over 1. That's 0 over anything because it's just 0. Then the last 2 sections, we lose cookies and we lose some more. So the whole point of these graphs are to help us understand what's going on in the story. So in this one, it's different than the last one in any graph that we've seen because of this section right here of the graph. Everything below our x-axis, this is negative. So if we had a story like this, we have to have an idea of why are we negative? Okay? So let's say we're running a race. Okay? We're in a race. Grab my pen again. Our x-axis, since I have some room right here, this is going to be the time in minutes, just like the last one. And this is our distance from the other racer. So we're in a race, just me and this other person. I'm running. At the start of the story, I'm 3. Let's say it's feet. Let's go feet. I'm 3 feet ahead of the other racer. But from A to B, since I'm losing distance, he's gaining on me. Right here, we're at the exact same spot. Now this racer is actually ahead of me. I'm behind him 2 feet. I'm still behind him 2 feet. I'm still behind him 2 feet. Then I start gaining on him again. And then I gain on him even more. Eventually, he starts gaining on me. Gaining on me. Here, we're at this point right here. We're at the same value. So we're tied right here. But then I gain on him again. So that's how we could kind of describe the story. Now I'm going to use this graph to help us answer some questions that are on our homework. So I'm going to erase a bunch of this. I just wanted to use it to tell a story just so you can see how all these graphs actually tell a story. Some questions that we might have or that we do have on our homework pages. I'm going to make this a little bit smaller so I can write around it. F of 8. Remember, this is an x value, so I come over here to 8 on the x. I come up to the graph. So if I plug in 8 to my function, it spits out 4. What about at 14? So 14, here's 14. Not a perfect whole number, we're just going to estimate. It looks like it's 0.5. We can use this graph to get any of our inputs. We could even wonder, all right, what about at, 4.5 is my input. So here's 4.5. It spits out -2. So if I plug in values, I can get my output values. We can also use this graph the opposite way. And those questions will say something like this. Where does f of x, where does our function, this whole graph, this whole thing's our function, equal 3? So where on this graph do I have an output of 3? So we actually do this in reverse. We come up here to the 3, and we look at where are all the inputs that will give us 3. Well, the first one's real easy. X can be 0. The next spot's right here, so we're going to have to do a little bit of estimation. It's not quite 7.5, so maybe 7.3, 7.4 in that area. And the next one is perfect and 9. So if I were to use any one of these three numbers, my graph would spit out 3. I could do this same kind of idea for any one of these numbers. Where does it give me 1? Where does it give me 0? Where does it give me -1? -1.5? What about way up here at 5? This one wouldn't work because nothing crosses up here. Just a few ideas. The last thing I want to practice is finding the slope of all these sections. So there are 3 sections. Or there's not 3 sections, that was in the last one, I'm sorry. 1, 2, 3, 4, 5, 6, 7 sections. Let's find the slope of each one. 1, 2, 3, 4, 5, 6, and then I didn't space it out, so I'm going to put 7 down here. All right, section number 1. The easiest thing, go from A to B. You know those 2 points are perfect, use them. You could use any other points if they work out perfectly, but you can see that no other dots are perfect, so we have to use A to B. Start from left, go right, just like a book. From A, 1, 2, 3, 4, 5 down. 1, 2, 3 to the right. There's the slope of the first section. Section 2, again, any points. 0 to 1, 0 over 1, 0 over 2 does not matter. 0 over 1 is the exact same thing as 0 over 2. It's the exact same thing as 0 over bajillion. Does not matter because 0 divided by anything is 0. Section number 3. Again, the only 2 points are C and D, so we go up 3 over 1. Yes, you don't technically need the 1, but it doesn't hurt to write it anyway. Section 4, 1, 2, 3, 1, 2, so up 3, right 2. And this is the best part from going left to right. You know your bottom number is always going to be positive because you're always moving to the right. We've got, all right, from E to F, that's 1, 2, 3, 1, 2, 3. So down 3, right 3, simplifies to -1 over 1, which we see because down 1, right 1 brings us to the graph, down 1, right 1 brings us to the graph, down 1, right 1. G is actually the exact same thing. Oh, the section 6. Last but not least, section 7, up 1, right 4. So that's analyzing our functions.